Hi, I'm Orina DaCosta from Fusion Quill. Welcome to our video series on AI education. The integration of AI and robotics isn't just about technological progress. It's about staying competitive, driving innovation, and strategically positioning ourselves for the future. Today, we look at the evolution of AI in robotics to understand how we've arrived at this pivotal moment. We'll explore current applications and opportunities. Lastly, we'll look ahead at future trends and discuss their potential impact on the business landscape. I would like to take you back to 1939. Meet Electro, the marvel of the World's Fair. Standing 7 feet tall, he could talk, walk, and even count on his fingers. But here's the catch. These early robots were about as adaptable as a vending machine that only takes exact change. They were hard-coded for a single task and single use. Specialists in one job and completely oblivious to anything else. Need them to do something even slightly different? Time to call in the engineers for a full reprogramming session. These machines did exactly what they were programmed to do. Nothing more, nothing less. Any change in the environment or task, and they would be as lost as a tourist without a map. What if we gave robots the ability to see, move, hear, talk, and react to their environments? And when you want them to do something different, download new programs on the fly. Remember when IBM's Deep Blue beat chess grandmaster Garry Kasparov in 1997? We were bearing witness to a pivotal moment in AI history. Why do robots need AI? Well, imagine teaching a robot to cook a simple meal. Without AI, it would only be able to follow pre-programmed recipes. With AI, the robot understands dietary preferences, adapting recipes on the fly, and even suggesting healthier alternatives. Robots operate in a real-world space designed for humans, filled with unpredictability. With AI, robots gain the ability to see, hear, and even communicate, thanks to sensors and cameras that process information much like our senses do. They can navigate new spaces, learn new skills on the fly, and recover from mistakes. Consider self-driving cars. You can't build one without AI. They need to interpret traffic signals, anticipate the actions of other drivers and pedestrians, and make split-second decisions to ensure safety. AI is the secret sauce that transforms robots from rigid, single-task machines into adaptable, intelligent assistants capable of handling the complexities of the human world. A robotic AI platform would comprise of these various components. For robots to become smarter and interactive, they require features that AI brings to the table. Features like computer vision to understand their surroundings, learn and adapt with machine learning, and make intelligent decisions through planning and adaptive control systems. AI also brings natural language processing and human-like interaction skills like gesture recognition and emotional intelligence. Zooming out of the robotic AI platform, let's see how it fits into the entire stack which makes up the robotic software platform. Building a robot starts with hardware, which provides the physical capabilities for interaction. Firmware manages this hardware, while the robot operating system connects everything, enabling communication. The AI platform and applications then add intelligence and purpose, allowing the robot to learn, adapt, and perform specific tasks. Humanoid robots are designed to resemble the human body, allowing them to operate in environments built for humans. These robots can navigate spaces and use tools without requiring significant modifications to existing settings. They can drive vehicles, operate machinery, and interact with keyboards and touchscreens. This compatibility reduces the need to redesign infrastructure. This adaptability allows a single humanoid robot to be programmed for multiple roles across different applications. Robots can assist in jobs that are dangerous, repetitive, or involve handling hazardous materials, all while operating comfortably in environments designed for humans.
The first law was that a robot couldn't hurt a human being or, through inaction, allow a human being to come to harm. The second law was that a robot had to obey orders given it by human beings, provided that didn't conflict with the first law. And the third law was that a robot had to protect its own existence, except where that would conflict with the first two laws.
We just looked at Asimov's 3 laws of robotics. Even though these laws are fictional, they remind us that as we design and deploy robots, prioritizing human safety must always be our guiding principle. As robots become more interconnected and intelligent, they also become potential targets for cyber attacks. Preventing hacking is essential to ensure that robots function as intended and do not become tools for malicious activities. We also need to ensure the robot's well-being by creating secure and protected areas for robots to maintain themselves. Let's focus on an essential part of AI and robotics: ethics. AI systems should be transparent in how they make decisions. Establishing legal frameworks and liability structures is essential for accountability and to guide ethical decision-making. Robots should be designed and used in ways that respect human dignity and rights. Designing robots that are accessible to all promotes inclusivity and prevents widening social disparities. At the end of the day, robots are tools, powerful ones that reflect the best of what we can create. With AI, they are becoming more than just machines. They are our partners in innovation. Thank you for watching this video. I would love to hear your thoughts. Let me know in the comments below what videos you would like to see next. And if you've enjoyed the video, don't forget to give it a like, subscribe to the channel, and hit the notification bell so you never miss an update.